Okay, so hello and welcome back. Write down with reasons another 5 angles equal to x. So I want to take a step back and read what was given here. In the diagram below, AB and BE are tangents to the circle. Let's see where that occurs. AB and BE. So there we go. There's the first one. Let me just get the pad out of the way. There's the first one. AB, that's a tangent, and so is BE. Okay, so there's my two tangents. That's the one and that's the other. There we go. Now, if you look carefully, that's the one tangent and that's the other tangent. The moment we got tangents and we got circles, we know we can use the tan chord theorem based on what I just explained in the previous video. Okay. Now, this gives me some kind of indication that AF equals FE. They tell me AF equals FE, and that's also very important because I'm going to make that yellow. AF, which is on this side, AF equals FE, and can you see that EA consolidates that and makes that a triangle? Now when that makes it a triangle, clearly you can see if this side and this side is equal, you get a specific kind of triangle. That's called an isosceles triangle. Okay, right. I know I tackled a little bit this earlier. AC, all of those are straight lines, and B3 is equal to x. Now, look very carefully, B3 is equal to x. Now, I'm just going to bring up a new page. So there's our x. I'm going to indicate that and make that x. Now, very carefully, B3 is equal to x, right? B3 is equal to x. And what other angles are also equal to x? Well, for starters, we can say if you look at EF and DB, EF and DB, those are two parallel lines. There's a parallel line and there's a parallel line. Now, when I have a set of two parallel lines, then I know I'm going to start using fun angles, right? There's a parallel line and there's another parallel line. I'm going to put it all the way down. It's been highlighted. Well, that parallel line is cut by a transversal, which I'm going to make in green. I'm going to color in that transversal. And if you look carefully now, I see a Z. I've got two parallel lines and then I've got a Z. So that means that B3 is also equal to E2. B3 is equal to E2. And if I give reasons, I have to say that that angle and this angle are equal. So that is called alternate angles. Alternate angles, and I need to say which lines are parallel. That is EF parallel to BD. Okay. So let's see if we can get the next one now. Okay, so that was our first angle. I've got one angle, E2, that is, and they wanted 5. So let's just remind ourselves which angle looked like X. That angle over there, that's X, right? So I've got E2. Now, if you look very carefully, let's see what other angles I can find that are equivalent to that. Now, let's see if I decide to highlight what we had earlier. We said that BE or EB, right, is a tangent. So there's a tangent. Okay, and we've just shown that E2 is also X. Now, if that's my tangent, this over here, from the one point to the other point on the circle, that is a chord, right? So if I've got a tangent and I've got a chord, that means I've got this angle as X, right? So now I look for the angle that is subtended by that. Well, look at this. Look very carefully. I'm going to subtend it to those 2 points over there and there. And so that clearly indicates to us that A1 is equal to what? Or let me start from what I've just ended up doing there. I've got E2. Now E2 is equal to A1, which is equal to X. And what is my reason there? My reason will be the tan chord theorem. The tangent is going to be EG or BE, and the chord is going to be EF, tan chord theorem. Right. Now, let's see what's next. Okay, so as we're going, we've seen a few different E's, right? So we know that E2 is X. Oops, Oops. That's a big no-no. Okay, let me just get rid of that. My apologies there. So clearly E2 is also x, right? That's a tangent, that's a chord. And now we can clearly indicate that A1 is also x. Now, if you see, A1 must be the same as E1 because of these two lines being equivalent. That was given, right? AF equals FE or EF, right? And clearly you can see that that is an isosceles triangle. So from there, I can say, because I've just shown that A1 equals x, I can say that A1 equals E1, which is also equal to x, and my reason there is an isosceles triangle. Okay, or I can say angles opposite equal sides. That's another reason. Angles opposite equal sides. Okay, now if we look very carefully, I've got one angle, E2, I've got A1, and I've got E1 that are all equivalent to x. Right, so there we go, there's another one, also x. Now, if you look carefully, remember these are parallel lines. BD is parallel to EF. So that means that this angle, if I draw that parallel lines in and I put it over there, if I draw it in over there, and I draw this parallel line, I've got a line that cuts through those two parallel lines. Ooh, mama. And the line that cuts through those two parallel lines is this transversal. Do you see that transversal going from the right down there? Okay, so now I can see clearly there and there. That's going to tell me that angle D, based on what I just showed, E1, I can now say E1 is equal to angle D. E1 equals D. These are angles. And my reason there is going to be that is not alternate, but that is corresponding angles with the lines EF parallel to DB. Okay, so now it's up to us to find one more. I've got E2, A1, E1, and D. Okay, so I've got that over there. Let's see what else. I've got 1, I've got 2, I've got 3, and I've got 4 angles. Now, let's see where's the fifth angle that I can find that's equivalent to x. Okay, so if we look carefully, if we look very carefully, what I'm going to do is I'm just going to erase these parallel lines so that we don't get confused, right? That's my bad. Okay, so I was in the process of erasing this quickly. Okay, and then just indicating that we've still got an x over there. Okay, so I see another angle. Remember, I've already shown that E1 is equal to x, right? E1 is equal to x. Now, if you remember, the tan chord theorem says, well, if I've got a tangent, over there, right, and I've got a chord, then the angle that's subtended by that chord, that angle that is subtended by that chord in the other part of in the other sector, which is over there, like such, that must also be equal to x. So we've shown that E1 is equal to x. That means that A2 is also equal to x. Now, that's because that's the converse of the tangent. We know this is a tangent, but we've already got this angle. So it means that angle must also be equal to x. We know that's x. We know this is a tangent. We know that's a chord. If that is x, then this must also be x, working a little bit in reverse from where we usually come from. So therefore I'm going to say that E1 is equal to x, which is equal to A2. So there's my 5 angles, E2, A1, E1, D, and A2. And again, the reason here is actually the tan chord theorem. Okay, so well done. We found 5 angles with reasons.